Hello class, welcome back to Darwin's Chem Corner. I don't know what that is, but okay. So before I talk about the math and the concept and what electronegativity is for in our last video. So right now I forgot to talk about this whole graph right here that you have to memorize during the exam and the quiz. So I'm going to talk about what it is really and I'm going to show you my dirty device and how to memorize it. So basically, this is the VSERPR models, and basically, this is how you name a formula. Name a formula, and you can't really do this until you draw the picture. So that's why the exam usually pretty tough because people don't really know how to draw the picture. So make sure you guys practice that. I can't help you with that, so you're on your own. But I'm gonna basically tell you, give you a big rundown what it means. I'm short. Calm down. Okay, so first thing first, remember we talk about electron, show the video. So in terms of naming, to find electron geometry, you have to look at electron pairs. To look for the molecular geometry, you have to look at the lone pairs. So basically, these right here, these with 0 lone pairs are the electron geometry. In exam, they're usually going to ask you for both electron geometry or molecular geometry. So right now, for the electron geometry, you're usually going to put these four different names. And I'm going to go over them. Where there's 2 electron pairs, it's called a linear. And basically because you're going to have an element I'm going to make some shit up, okay? So CO2, right? C is going to be like this, and O is going to be like this. This is a linear because it's a straight line. And remember how I talk about that when a formula is linear, it's always going to be non-negative because O should be more electronegative, meaning that these electrons are going to get stuck. So that's why it's non-polar. So, and the nice thing about linear this section right here is when there's an electron of pairs of 2, it's going to be linear for both electron geometry and molecular geometry because there's no lone pairs, so you don't have to worry about that. So the next one is trigonoplanar. Trigonoplanar is basically like what it says, three different pairs. So let's just say K. Let's not do K actually. Let's do C, C, C. So basically, when you have three different pairs, it's a trigonoplanar, and a trigonoplanar will be bent if it have a lone pair like this, because so it's without this lone pair, it's just gonna be a trigonoplanar. With the lone pairs, it's gonna be bent, and the reason why they call it bent because of this this lone pair will make the angle it will shift it a bit. So just so you know that trigonoplanar have take 2. So when your formula has an electron pairs, they could be 2 names. Could be. It's either a trigonoplanar without the lone pairs, or with the lone pairs is going to be a bent. So keep that in mind. The next one is a tetrahedral, and the way I memorize tetrahedral, because tetra literally means 4. So if you get an element like this, there's 4, and when you think 4, think tetrahedral. And with tetrahedral, there's sadly 3 different names you can have. For the molecular geometry, let me reiterate that from here. So right now we need to determine the electron geometry, right? The electron geometry, let's look at electron pairs. How many electron pairs does this CN have? 1, 2, 3, 4. What do you call a shape with 4 pairs? Tetrahedral. So now we gotta look for the second part. The molecular geometry, and how many lone pairs does this shape have? So right now, the way I drew it, there's no lone pairs. So the electron geometry and the molecular geometry is going to be a tetrahedral. As weird as it sounds. So let's add a lone pair. Oh look, there's a lone pair now. What's the molecular geometry for this formula when it has 1 lone pair? It's called a trigonal biopyramidal. And vice versa, what when you add another lone pairs? It's called a tetrahedral bent. And basically, it won't go more than that. So I will reiterate, If it has no lone pairs, we're just talking about molecular geometry, right, guys? Because we established that electron geometry is just tetrahedral. So now we got to determine the molecular geometry. The molecular geometry for this right now is just, again, right here it says there's no lone pairs, right? So it's tetrahedral again. So you can say it's a tetrahedral. So electron geometry, then molecular geometry. We're going to add a lone pair. So now it's a tetrahedral trigonal bipyramidal.
No, just trigonal pyramidal. There's no bi in front of it.
Holy shit.
Yeah. It's
Trigonal pyramidal.
trigonal pyramidal.
Fuck it. You know what I mean. You can read. And if you add another lone pair, it's going to be called a tetrahedral bent. And if you play with the toys, you can see why they call bent and pyramidal, because if you look like this, you look at 3D, it will be an actual pyramid, but you don't care about that, do you? So that's tetrahedral. The next shape, let me think of XE. C. This doesn't exist, okay? But so now we're gonna talk about 5, and like I said, the first thing you want to do is find the electron geometry. And as I said, electron geometry is what? The shape of only electron pairs. 1, 2, 3, 4, 5. What do you call the shape with only five electron pairs? Trigonal bipyramidal. Now we gotta think. Now they're gonna pull some tricks on you. They might add a lone pairs. So now you already determined the electron geometry, which is trigonal bipyramidal. Now you define the molecular geometry. As we stated, that since this is a trigonal bipyramidal, we gotta figure out what's the second name. It's like a last name, kind of this lone pair. So it has one lone pair, and what do you call that? Seesaw. Okay. Seesaw. Right here. One. So now we're gonna add another lone pair. So now it has 5 electron pairs and 2 lone pairs. And what do you call this? T-shape. And now you're gonna add a third one. And what do you call this? It has 5 electron pairs, trigonal bipyramidal. It has 3 lone pairs, linear. And if you draw it properly, this is gonna look linear, but I'm lazy. You don't have to worry about that. You do actually, it's your exam. So, but you guys getting the concept, right? It's just like, I would just do it because I'm already there. So now we're gonna look at
2F. Oh, you could do SF6. That's a real one.
Now I know.
Just a reset. Just finesse.
So now we're gonna look at this, and like I said, the first thing you do, you look for the electron geometry, which is by looking at electron pairs. There's 6 electron pairs. When there's 6 electron pairs, it's called an octahedral. And I know oct means 8, but just go with it. And right now, you gotta see how many lone pairs does it have. No lone pairs, so it's still called an octahedral. We're gonna add a lone pair right now. Oh look, it's an octahedral with 1 lone pairs. And what do you call that? Square pyramid. Vice versa. Oh no, it's an octahedral with 2 lone pairs. What do you call that? A square planar. So that's how, it's really simple. You guys got this by now. You're probably skipping the video. So that's how you determine electron pairs and lone pairs. So remember, you're usually going to have to name the electron pairs and the electron geometry and the molecular geometry. Did I make sense? Okay, take 2. I'm sorry. You're usually going to name the electron geometry and the molecular geometry. The first thing I would do, and I think you should do, is determine the electron geometry, and by looking at electron pairs, because it gives you the basics of what you need to know. And the molecular geometry is just an extension of the electron geometry. So I hope that makes sense. My biggest recommendation is to print out the PowerPoint slides for your molecular modeling lab, and to print out this packet again, because this packet's actually amazing help. I have some of the answers. Some of them are wrong, but just like 2 of them. So if you want the answer for it, come to me and I'll give you it. But you guys really need to practice this packet, because that's basically your quiz. So right now, I'm going to tell you like a mnemonic device how to memorize some of the list, because this is a really big list, right? Come on. There's gotta be a way to memorize it. And when I was tutoring my friend last semester on this unit, she made a mnemonic device that stuck to me forever, okay? So right now, this is the first mnemonic device is to memorize 2, 3, and 4. Got it? 5 and 6 is something different. So right now, to remember the geometry, look at the first letter of these terms. L, T, B, T, T, B. So like I said, I just copied the first letter to memorize this. And this is the dirty mnemonic device that I told myself to memorize this. You ready? I can't take myself seriously. Ready? Lick the booty to timing bastard.
Or bitch.
Or bitch. I like bastard more. So, serious, professional. So the way, I literally said this during my exam quietly because it would be really, really awkward if I said it out loud. Lick the booty, 2-timing bastard. And I can't really tell you how to memorize these different T's. It just it helps you organize your chain of thoughts. If you're stuck in what the name of after drawing drawing the figure. So right now, if you ever get stuck, you don't know what the name of it, if you know you have a linear, a trigonal planet, or a trigonal pyramid, just write this down. Lick the booty, 2-timing bastard. Lick linear, the trigonal planar, booty vent. 2 tetrahedral, timing, trigonal pyramid, bastard, or bitch, bent. So I know it went by quickly, but you guys can see the comparison right now. So to memorize this first half, just know lick the booty, 2-timing bastard. Or do whatever you want, I don't care. The next mnemonic device to memorize is just for the trigonal bipyramidal. So when there's 5 electron pairs. So you see how trigonal bipyramidal have 3 different names? I found myself very hard to memorize this in the correct order, and it kind of dawned to me the word still. To memorize the order of the lone pairs for a trigonal bipyramid, remember the word still, okay? So S for seesaw, T for T-shape, L for linear. So if you have a trigonal bipyramidal with two lone pairs, just write the word still. The first term is 1 lone pair, the second term is 2 lone pairs, and the third term is 3 lone pairs. And like I said, the picture draw has 2 lone pairs. 1, 2. Oh, 2. T-shape. That's how I do it. If this worked for you, God bless, but it doesn't work, I'm sorry, I tried.
Can I give my way to memorize trigonal bipyramidal?
Yeah, so
it's just tri and bi, 3 and 2 equals 5. So
yeah, I think you need to show that.
Oh well, it's just hold on.
So Cassidy, I actually have another way to memorize this. If you want to hear it, go on. Don't die.
Can I see this marker?
Yeah.
All I do is, because it's 5, this is the order it goes in, and to memorize the name of it, it's just tri and bi. Those are the prefixes for 3 and 2, and 3 plus 2 is 5.
Oh
Don't
shit!
clap.
I didn't know that. See, yeah, that's
Wait,
really
I can
smart.
take the
Oh yeah, okay, that's really smart. The way to memorize octahedral, I got nothing.
I said os.
I got nothing. I don't know what os mean.
I just have os in my head. OSS.
OSS.
Wait,
But still.
Spy Kids. Isn't the OSS from Spy Kids?
Dumbass.
Okay, well that's
Come on,
just
guys.
the OSS is Spy Kids. Octahedral, square pyramidal, square planar.
Yeah, I just memorized that I'm not gonna draw it. I have a way to memorize this, but it's more visual. I'm gonna do it but if you guys get confused, just stop listening. So I think of a pyramid for octahedral because they're both square. The top right here is actually the pyramid shape. The bottom is actually like a square shape, like a square pyramid. But no, never mind. I just contradicted myself. Never mind. So yeah, I'm gonna reiterate to memorize this model. Understand the first half. The first half, which is 2, 3, and 4. Lick the booty 2 times faster, just to help you organize yourself of your chain of thought. For if you ever get stuck on trigonal bipyramidal, remember the word still. The first term is S for seesaw. The second term is T for T-shaped, and the third term is L for linear. And right now, the one thing that you notice that I didn't talk about in this chart is the angles. In a test, they want you to list the angles. I don't know why. It's bullshitty, but you have to. But they're not hard to memorize. What's a linear graph looks like? A straight line. What's the angle of a straight line? 180. The trigonal planar, I literally can't.
They go in a descending order. So if you just know 180, 120, 109, 109.47.
They do go in descending order except for tetrahedral.
What goes 90, 120?
Yeah. Just know that octahedral has square in both names, right? A square has 90 degrees. Just memorize that. So linear is easy to memorize. Octahedral is easy to memorize. The other three, I guess you guys are on your own. I just memorized last semester that they're going in a somewhat descending order. I said somewhat because this contradicts my theory. So if you can memorize that trigonal is 120, God bless you. And I'm going to teach you something really important. Not really important, it doesn't matter a lot. That we're naming angles. So we're going to look at H2O, right? H2O, what shape is it? It has 1, 2 electron pairs. And when you have 2 electron pairs, it's called a linear. It wouldn't hurt to check. I'm kidding. It's not 2. It's 1, 2, 3, 4. My apologies. I just confused a lot of you. I'm sorry. But yeah, we're gonna look for H2O, right? You have to look at all the pairs connecting from the middle. So right now you got 1 pair, 2 pair, 3 pair, 4 pair. They don't have to connect when it turns to electron pairs. You just gotta determine the amount of pairs within the middle element. So like I said, 1, 2, 3, 4. And what's an element that has 4 electron pairs? Tetrahedral. But now look at this element. It has lone pairs. How many lone pairs? 1, 2. Right? So what's an element called when it has 2 lone pairs? Bent. So if I'm gonna name this, I would have named it tetrahedral bent. So that's kind of like the process of naming it. And now the angles. What is the angle for a tetrahedral? 109.47. Easy. But I don't know if your professor required you to do this, but my TA did. He told us that this concept remember my spaceship analogy, and how this lone pair is gonna suck out electrons. This process makes the angle smaller. So if you want to be technical, the real answer for this one is 109.47 is greater than X. Usually, I don't think professors worry about it. My friends didn't do this and they got full points. But if your professor makes you do it and they talked about it, follow this rule. So I'm sorry that I confused you guys on this part. It's when you're looking for electron pairs, you want to look at all the pairs surrounding the middle element. In this case, the middle element is O. And when you're looking at lone pairs, just look at these because they're not connected
Can I
anywhere,
ask
so
a
there's lone
question?
pairs. Okay, yeah, go ahead.
Do you remember when we were doing SF6 and then you added a whole bunch of lone pairs to it and there were like 12 electron, no, there wasn't like 12. There was like 8 electron pairs at once. There's no name for that.
Yeah, no, that was just like it was just like a
Yeah,
random
it was
thing
just
like
like a
that.
fake kind of thing.
Yeah, it was a fake.
Yeah.
I was just showing you an example how to understand it. But right now,
So what if you have like 4 electron pairs when 2 like
Lone
lone pairs, would that technically be octahedral because there's 6 electron pairs?
No, because usually it's gonna look like this. Let's just say we're gonna use like C O O. It's gonna look like that.
Okay.
So
is that
1,
not
2, 3, 4, 4 electron pairs, tetrahedral. 1, 2, 2 lone pairs, bent. That's how they're gonna look.
So
But-
that's not 2. That's not linear.
Hmm?
So that's not linear then.
Huh? No, it's not linear, because remember, like I said, like these lone pairs are going to change the angle of
Okay.
your thing. So it technically is going to look like this. That's why we have this type of concept right here.
Okay.
So it's not gonna. The way I drew it is linear, but you're not supposed to draw like you see how H2O, it could have looked like that, but I didn't draw like that because
Okay.
of this. So right now, like Cassidy said,
I just wanted to clarify.
yeah. So a tetrahedral bent is gonna look like this: 1, 2, 3, 4 electron pairs, but 2 lone pairs. If she meant this, what is it called? So let's
Yeah, that's
try,
what I was talking
let's
about.
try this example, okay? So how many electron pairs does this this formula have? 1, 2, 3, 4, 5, 6. When we have 6 electron pairs, it's a octahedral. But now we gotta look at the lone pairs. So just the circles. 1, 2, square planar. And what's the angle for this? It's gonna be 90 degrees. And you can do this all you want, but I don't care. So right now, I hope this, the point of this specific video was to help you understand a bit and memorize this chart in a more easier way for you, because this is a very big chart, but it's very simple to memorize. And if you just memorize, like the booty to time bastard, and still, you'll be fine. And this part, you can make a bazillion things to memorize this. Just understand that electron pairs, like I said, it's the middle element and all the pairs around it. So this is a pair, 1 pair, 2 pair, 3 pair, 4 pair. And when it comes to lone pairs don't connect to anything else. So you see how this pair connects to O and H? That's not a lone pair because it connects something. So this right here, since it doesn't connect to another element, it's called lone pair. So understand that concept, all right? Got it.